Hi, my name is Matthew Spitz, and today I will be taking you through my pitch prediction model. So the goal of this project is for the user to be able to enter data about a certain situation in a game and for the model to predict what the pitch type will be of the next pitch. So in order to do this, you need to have a few data sets as CSV files on your local machine. One is a data set of every single pitch from the 2016 Major League season provided by Sportradar, which was accessible via Google's BigQuery data warehouse. So you need that on your local machine, and then you also need a few data tables from Baseball Reference, one on team batting from the 2016 season, one on individual player batting, and one on pitching. So once you have all those data sources on your local machine, you're ready to start. So the first step after you have those data sources, which I've already extracted for the purposes of this tutorial, is to run a Python script called python main processing.py. So the first thing the program prompts you with is it asks you to extract the features of the model. I'm going to answer no. If you haven't done this before, you need to answer yes, because it's going to take all those data sources, clean the data, and create a CSV file of all the extracted features. It's going through 2 gigs worth of data, so it takes a lot of time. It takes a few hours, so I've already completed this step. But this is necessary in order to train the model. So after that step, now you can say yes, you want to predict pitch type based on a specific event. So in a second here, you will get prompted with a bunch of questions. Each question corresponds to one of the 20 features. So first it asks you what pitcher would you like to make a pitch prediction for, and I'm going to put Justin Verlander. If you spell a name of a player wrong, the program will let you know, and you have to type in the correct name. So now I'm just going to enter a series of data for all the questions, and some of it will be true, some of it won't be, just for exemplary purposes. So what hand does the pitcher throw with? Right. How many pitches has the pitcher thrown thus far in the game? I'll say 10. It's the beginning of the game. Who's the batter that the pitcher's facing? I'm going to say David Wright. He's my favorite New York Met. What side of the plate does the batter hit from? Right. How many pitches does the batter face thus far in the at-bat? Let's say 3. What is the weight of the batter? 200. Height of the batter. What inning is the game in? I'll say it's the first inning. How many batters does the pitcher face this far in the inning? 3. How many balls does the pitcher thrown this far? Bat, 0 balls, 0 strikes, 1 out. The run differential is 0, so it's a tie game right now. What is the average OPS of the batting team? Say 700. Of the hitter, 750. Average ball and play percentage for the pitcher, I'm going to say 20.0. Average speed, 98.5, very fast. Average location, 5.5, which is around the middle of the plate. And what stadium? Citi Field, where the Mets play. So that's done. So once you finish this step, you will see that a CSV file is created with all the feature data. This is the same format as all the training data that is used on the model. Okay, so we're done with that. Now we have to hop over here to the right terminal, which is my Spark. It's where all my Spark files are on my computer. And we have to run this line, which it calls the Spark submit executable, which is necessary to run the PySpark code that's in my main model py file in terminal. So it also takes 2 arguments. The first argument is no or yes. You have to input either no or yes. I put no because this is asking you, do I want to train the entire model and make predictions based on a 20% holdout test case and test the accuracy of the model? I'm going to say no because this is not what we're doing for the purpose of this tutorial. What we're doing is we're using the data that we just entered to make predictions, to make a prediction on pitch type on that one row of data. So I'm going to put yes for the second argument because that corresponds to, do I want to make individual predictions based on that individual prediction.csv file I created. So I'm going to say yes. However, you do have to say yes for the first argument if this is the first time you are running this, because as part of the first argument, what happens is that there's a pre-processing phase where all the features are converted to a vector form from that original CSV file, and that's necessary to train the model. So let's run this line. And what's happening here is first it's going to create the user entered features into a nice Spark data frame, and you can see that here I'm highlighting currently the table that the Spark program just created of all the features we entered. Hopefully the video is caught up and you can see this on your screen. And now what's happening is it's training the entire model. It's a gradient boosted classifier, and I'm performing a binary classification where I'm predicting, the model's predicting if it's a fastball, the pitch type, or a breaking ball. The reason why I made a binary here is because a hitter has less than 1 second to make a decision on what type of pitch it is and how they're going to swing. So normally they're just deciding, is this a fastball, meaning is this a faster pitch that's straighter, or is this going to have more movement and be a breaking ball, be a little slower? And the breaking ball category consists of more pitches, but based on who the pitcher is, there's certain types of breaking balls that he'll throw, so he'll generally know what to expect. And just knowing this differences between these two things can create an incredible advantage for the hitter, which is seen in this past World Series when Hugh Darvish was caught tipping his pitches, and the Astros players knew what type of pitch to expect, and they won 86% of their at-bats against him, and he only pitched very few innings in the World Series because of it. So now the program is finished, and you can see here that it predicted 0. 0 meaning is a fastball, 1's a breaking ball. The 100 is just a dummy label, and here's the feature vector. And now if you go back to the terminal on the left and you pull up another file called pitch predictions, you can see the full feature vector, you can see the prediction of 0 and the probabilities, and then in a matter of minutes you just entered in your own data for a given game situation and have a predicted pitch type result. So the goal is for this to be rolled out with a Major League Baseball team. There's obviously latency issues here that it takes some time to run the code, and there's still a lot of room for the model to improve. Right now it's at 62% accuracy, and those are kind of my next steps in this project. And I want to thank you for watching this tutorial, and have a good night.